Thank you, Michael. Thank you all for coming. Fantastic turnout. I was expecting about 20 people. I do have some DNA kits. I hope there aren't more than 10 people going to be fighting them over them at the end of the lecture, because I only have 10 left. There are more being shipped from the States, so we'll have more at future events. I'm going to talk for about half an hour about the science and the methodology behind using DNA to find your long-lost relatives, and then the second half hour I'm going to give some examples from West Clare of cases where DNA has helped to solve puzzles in family history. I'm recording this, so I hope that the audio and what's going up on the screen will go up on YouTube in due course. If you want to go through the notes and follow the links, you don't need to write everything down. If you just take down that address, pwaldron.info/DNA/Kilrush, and it is case sensitive, DNA uppercase and capital K for Kilrush, and you can look at this material afterwards. What is DNA? Well, we call it DNA because it's much easier than getting your tongue around deoxyribonucleic acid. It's about the second time in my life I've uttered that phrase. You don't really need to know a lot of the jargon that's going to be thrown at you. I'm going to try and keep the jargon to a minimum. DNA is made up of molecules with, again, complicated names that you can immediately forget: adenine, cytosine, guanine, and thymine. We'll just call them A, C, G, and T. So you can just think of your DNA as a long sequence of letters that can be read from the molecules that make up your body. Where does DNA come from? Well, some of it comes from our father and some of it comes from our mother. When a sperm meets an egg, the sperm has either a Y chromosome or an X chromosome. If it has a Y chromosome, the end result is a male. If it has an X chromosome, the end result is a female. The sperm also has another 22 chromosomes, which are called the autosomes, or the autosomal chromosomes. They're what we mostly use in family history research, certainly in the examples I'm talking about today. The egg has an X chromosome. That means a male has a Y chromosome and an X chromosome. That's what makes you male. If you're male, you have a Y and an X. They're different lengths. If you're a female, you have two X chromosomes. The egg brings another 22 autosomes, so you end up with 22 pairs of autosomal chromosomes. And the egg brings mitochondria. So that's the part of the DNA that comes down mother to daughter. The Y chromosome comes down father to son. The Y chromosome comes down your family tree like your surname. You got it from your father got it from your grandfather got it from his father, father's 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 father, all the way back along the line, the same as most people get their surnames. The X chromosome is a little more complicated, because a man has one, a woman has two. You can basically get part of your X DNA down any line in your family tree that doesn't go through two consecutive male generations. So you can get it from your father's mother's father's mother, or your mother's mother's father's mother, but you can't get it from your mother's father's father, because that's two males in a row. There's a little picture here just showing you, this is a fan chart family tree. Father there, mother there. This is intended to represent a male. The male gets the X chromosome from the mother. The father only brings a Y chromosome. So the X could come from your mother, who's there in pink. It could come from your mother's father or your mother's mother. But it can't come from your mother's father's father. So that whole part is blank. That can't be a source of your X DNA. We don't really use that except when we're getting very sophisticated in doing family history work. What we use for most of the family history work are the 22 pairs of autosomal chromosomes. So you get half of that from your father, half of that from your mother. Your autosomal DNA equally reflects your father's side and your mother's side. Go back another generation, there's a little random element, but on average, a quarter of it comes from each of your grandparents, an eighth of it comes from each great-grandparent, a 16th of it comes from each great-great-grandparent. So as you go back through 5 or 10 generations, the amount of DNA that you get from each ancestor becomes quite small, and eventually there'll be some ancestors that aren't represented at all if you go back about 10 generations. The mitochondrial DNA comes down from your mother, your mother's mother, your mother's mother's mother, your mother's 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 mother. So it can be useful in special cases, like you might have two McNamaras living in West Clare 6 generations back, and you might wonder, are they brothers or are they sisters more likely, or more distantly related? If they are sisters, and if you can trace a direct female line descendant of each one and compare their mitochondrial DNA, they'll have the same mitochondrial DNA. If they're not sisters, they've different mothers, they won't. So again, that's for the more sophisticated analysis. I'm going to try and keep this to the really basic beginner stuff and then the examples. So beginners are always advised to start with the autosomal DNA, the 22 pairs of chromosomes that come equally from the father's side and the mother's side. How much DNA do we have? An awful lot. If you printed out the letters representing the DNA in one cell in your body on paper, they would fill this whole building, roughly. We have 6 million letters, 6 billion letters in every cell representing our DNA. But most of those are identical for all human beings. A lot of them are identical for a lot of the apes as well. What the scientists are doing are looking at what are the locations on the chromosomes where there is variation from one person to the next. And if we find something that varies from one person to the next, two people who have the same letter at that location that varies are more likely to be related, are likely to be more closely related than two people who have different letters. So out of those 6 billion letters for the genealogical analysis, we only look at about 0.02% of the total. There's 3 big companies which do this work. They're all based in the US. Your samples go to a lab in America. Your results come back via a website. And they look at somewhere between 400,000 and 600,000 out of the 6 billion letters in every cell in your body, because they're the ones that vary from one person to the next. So if DNA came down unchanged from parent to child, it wouldn't tell us anything. We'd all be identical. What's interesting is that there is a certain amount of random variation from 2 sources. You can have what's called a plain mutation. A letter in your father's or mother's DNA can just switch to another letter at the point of your conception, and then you're different at that location from your parent. And some of these locations mutate very frequently. You learn about the criminal justice authorities using DNA to identify criminals. What they look at in DNA are the locations that mutate every couple of generations. So that means that the only 2 people with the same values on all those fast mutating locations are identical twins, or the criminal and the man who left his DNA at the crime scene. Well, somebody did send me a little clip this morning of a case where a man did 5 months in jail because his DNA was found on the finger of a murder victim. And he eventually managed to convince them that he was in hospital at the time the murder was committed. He'd been brought to hospital by the same ambulance crew that had brought the murder victim to hospital. And they put an oxygen sensor or something, clipped it on the man's finger, on the patient in the hospital, and on the murder victim. So the DNA of one person in the ambulance was transferred to the other person who was in the ambulance an hour later, and suddenly the first patient became a murder suspect charged with murdering the second one. But the DNA had been totally accidentally transferred. But what we want to look for genealogy is locations that might mutate every 10 or 20 or 30 generations. And then people who have the same mutation in those locations are quite likely to have got that from a common ancestor, maybe 5, 10, 20 generations back. I'll just say a little bit about the Y DNA that comes down from father to son. There's 2 types of mutations that are looked for on the Y chromosome. One is called the STR. It's a sequence like this where you have 4 letters CCTG and they're repeated maybe 7 or 8 or 10 times. The number of times they're repeated vary from one person to another, and that's a good marker of a relationship. 2 people who have 7 repeats are going to be closely related, but they're not as closely related to people who have 9 repeats. The other one is called the SNP. Again, you don't need to worry about the jargon, the single nucleotide polymorphism. That's a single location that just switches probably once in the history of mankind. So the most famous SNP in County Clare is called L226. There's so many of them, they just get a letter and number to identify them. L226 they now call the Brian Boru SNP, because all the O'Briens and the Kennedys and the other families that are related to the O'Briens, according to the annals, tend to have this L226 mutation. Other people don't have it. So you can actually maybe just look at one location on your Y chromosome and say, you're probably a Clare man. You probably have a Clare surname. Okay, surnames don't always follow the DNA. There's all sorts of reasons why somebody might take a stepfather's surname, might take the mother's surname to inherit the mother's family land. Somebody might have been unfaithful and the father might not be the father expected, but generally the surname goes down with the Y DNA from father to son. So we can look at these 37 basic STR markers in surname projects. Hopefully this will work. This is the Clancy surname project. My great-grandmother was Mary Ann Clancy from Killard near Doonbeg. So I have set up this Clancy project to try and confirm some of the family myths. I was brought up to believe I was related to Paddy Clancy, who was sentenced to death in 1916. Never been able to prove it using conventional genealogy on paper. I'm hoping that I'll persuade one of Paddy Clancy's known relatives. Rico isn't here tonight, no? I'll be calling to him with a DNA kit because he has a known paper trail to Paddy Clancy. So you can see in this picture, group 1 here, the orange group, are the County Clare, Ireland Clancys. We have 8 people in the group. The top one, he's Cranel because he has an adoption in his line, but he knows that somewhere along the line a Clancy was adopted and became a Cranel. The second one is my cousin descended from Hugh Clancy of Killard. The third one is a Clancy descended from Emla out near Moyarta. The fourth one is a Costello who doesn't match as closely as the Clancys match each other, but he's quite close. As you can see, the 3 Clancys at the top, there's only one difference. The Costello, there's only one difference that you can see there in the 4th row, but if you scroll over, he has a few more differences further over. So basically, if the 37 markers are all the same, you're probably very closely related, maybe 2nd or 3rd or 4th cousin. If there's only 10 out of 37 the same, you're no relation at all. And Clancy is also a County Leitrim name, and we have 3 groups of Leitrim Clancys. Well, one group and then 2 strays who don't match up with the others. I put them in separate groups. Then there's a Clancy in Limerick whose closest match is actually an O'Donnell. And again, he has the family legend that he's related to Paddy Clancy, but the DNA says we can't both be related to Paddy Clancy, and if we get one of Paddy Clancy's known relatives, that'll prove who is. Then we have one in South Carolina, doesn't know what part of Ireland they came from, doesn't match any of the others. And then we have the interesting one, the Wexford Clancy, who's completely different DNA signature to the Clare Clancys, even though some of these now live in Kilrush. And the people they most closely match are the Tuckers in America. And the Tuckers are absolutely delighted. They have been looking for years and years to see, have we anyone in Europe whose DNA we match? Where in Europe did the Tuckers come from? And it now looks like the Tuckers in America are really Clancys, or else the Clancys in Wexford are really Tuckers. And again, that could have happened 10 or 20 generations back. We can't really tell exactly. So there's a couple of links there to Marinans and O'Briens. I won't go through them because otherwise I'll run out of time very rapidly. And using the other type of marker, the SNP marker, which only mutates once in the history of mankind, people have built a haplogroup tree. Originally, when they did this, they thought there's only about 20 types of Y chromosomes. We'll call the first one A. There's an awful lot of variants of A, and eventually when we scroll down, somewhere we should get to the subgroups of A, A1A, A1B, and then B, then D, E, F, G, all the way up to OR. Most Irish people belong to haplogroup OR. In fact, now there are thousands and thousands of more refined haplogroups. They're discovering new ones every day. The technology has developed at an amazing rate in the last 10 years or so. I have Moore's law in computing, which says that the speed of computers doubles every 18 months or something. But that doesn't apply to genetics. It doubles far more quickly than that, the level of knowledge of the Y chromosome and all the chromosomes. Did the same thing with the mitochondrial DNA that comes down from mother to daughter. I won't go into the details of that. But what I will try and explain briefly is how the 22 pairs of autosomal chromosomes that your father had and the 22 pairs of autosomal chromosomes that your mother had turn into the 22 pairs that you have. You get half of your father's and half of your mother's. And what happens when the egg or the sperm is created, each pair of chromosomes, the two chromosome ones, recombine and they cross over from point to point. So this is a stylized example that I made out here. The top line in blue is the father's sequence of A, C, G, and T. The second line in red is the paternal chromosome. And when an egg or a sperm is produced, the first 20 letters or so there, the blue ones, they're taken from the paternal. Then there's a crossover. The next 20 or so, the red ones are taken from the maternal. T-A-T, C-A-G, the red matches the red. And then after another while, there'll be another crossover and it'll cross over to the blue. And there might be 2 or 3 or 4 of these crossovers on each of the chromosomes. And you just get this random combination of, from your father, a random combination of your paternal grandfather's and your paternal grandmother's DNA. And you have to try and figure out which bits came from which ancestor. There's 3 numbers that are used to measure the length of a segment of DNA, which is the same across 2 people. One is the number of letters in that 6 billion book that fills this room. The second one is the number of actually observed letters that we know vary from one human being to the next. The third one is a thing called the centimorgan length, another piece of jargon. That's basically an estimate of how recent the common ancestor was. The rate at which those crossovers take place vary along the chromosomes and from one chromosome to the next. I gave you an example there where it looked like there was a crossover every 20 letters or so. In fact, they happened about every 19,000 letters on average. You'd be scrolling halfway down Moore Street to find the next one. So how do we know that 2 people are related? We look at these long sequences of letters. But the problem is the technology cannot tell us when it looks at location 1 on chromosome 1. There's an A and a C. It can't tell us, did the A come from the father and the C from the mother, or the A from the mother and the C from the father. So we have to do some little bit of statistical inference. So it's really a kind of double negative calculation. So 2 more bits of jargon. If you have 2 different letters at a location, an A from your father and a G from your mother, we call that heterozygous. They're different. If you have the same letter from your father and your mother, an A from your father and an A from your mother, we call that homozygous. The 2 zygotes are the same. So if you have 2 individuals who are opposite homozygous, an AA and a GG at that location, they can't have got that location from a common ancestor because the 2 letters are different. If you have an AA and an AG at the same location, they might have come from a common ancestor because they both have an A and the common ancestor might have had an A. If you have 2 AGs, you might have 2 common ancestors. The 2 A's might have come from a common ancestor on your father's side, the 2 G's might have come from a common ancestor on your mother's side. So I'm going to look at this other example. I have to move these to a separate file. So here's person 1, paternal chromosome in the top row, maternal chromosome in the bottom row, and then a second person, paternal chromosome in the top row, maternal chromosome in the bottom row. The first location, person 1 has an A and a G, person 2 has an A and a G. Sorry, I shouldn't say paternal and maternal. We don't know at this stage where the letters came from. We're just looking at pairs of letters. So that first location could have come from a common ancestor with an A or from a common ancestor with a G, or maybe it didn't. maybe the G is opposite sides from the A. But if we move over here, the ones I've highlighted in red, person 1 has 2 C's, person 2 has 2 T's. That location did not come from a common ancestor, because the common ancestor couldn't have both the C and the T in that location. There's 2 G's and 2 T's. That couldn't have come from a common ancestor. But when we move over here, there's a longer spell where there's no opposite homozygous locations. That's called a half-identical region. That's a region where there could be a segment that's identical in both people. But if we have maybe 1,000 letters where we can't rule out the possibility that it came from a common ancestor, then we begin to think seriously. There probably is a common ancestor here. Short little runs don't mean anything. Runs of about 1,000 mean that there must be a common ancestor somewhere back along the line. So we end up looking at sequences of numbers. Chromosome 5, beginning at location 149 million, ending at location 169 million, 27 centimorgans long, 2,443 letters observed, and we can't rule out that it came from a common ancestor. If it's well over 2,000, it almost certainly did. And this is a comparison between, this is one I just looked at this morning. John is a Blackhole descendant in Liverpool. Ger is a cousin of mine who descends from the Blackholes of Killard. So we've good reason to expect that they're related. The 2 Blackhole families, well, the Liverpool ones know their ancestor came from somewhere in Clare. There's an unusual name, Marcella, which is a very common name among the Blackhole descendants. It's in both the Clare family and the Liverpool family. So we're not surprised to find that they have some shared DNA in common. So when you send off your DNA, you get a number of things back, but the most interesting one, I think, is the list of who are your closest relatives in the DNA database. And these are my top 4. Mary Durkin is my first cousin. She's marked red because it has worked out that she's on my mother's side. She's from Mayo. Anthony is my first cousin on my father's side. He's marked blue. John Durkin is another first cousin on my mother's side. Paul Waldron is a first cousin once removed on my father's side, and so on. And you will get this list, and for each one, you can actually look at the segments of DNA that I share with them. These are my first cousins. I'm going to share lots of segments of DNA with them. About a quarter of my DNA is in common with my first cousins. That's the 22 chromosomes laid out. They're all of different lengths. The orange bits are the bits where I am matching my first cousin. The darker bits are the bits where I'm not matching my first cousin. And we can view it all in numeric form as well if we prefer numbers to graphs. Most people prefer graphs to numbers. I'm a mathematician. I prefer it the other way around. So in chromosome 1, I match my cousin Mary from location 5 million to location 26 million. It's 36 centimorgans, and there's 6,000 consecutive SNPs there where we appear to match. There's another one down there in chromosome 3. I wouldn't pay as much attention to that. It's only 500 SNPs in a row. But you can see 9,000, 7,000, and centimorgan numbers up in the 20s and 30s. So numbers like that are very clearly from common ancestors. But sometimes there can be false positives. You can have a bit of your paternal chromosome matching somebody else's maternal chromosome, and that might overlap with a bit of a maternal matching the paternal. And it's very hard to measure exactly where these matches begin and end. They have usually what they call fuzzy boundaries. So it's not an exact science. It's more an art than a science. But the rule of thumb is if it's very long, there's a common ancestor there. If it's shorter, you've got to look a little more carefully to see is there really a common ancestor. Next thing you want to do is work out on which side of the family is the relationship. If you have 2 people who match each other in the same region, sorry, let me say that again. If you have 2 people who match you in the same region, and they match each other in that region, they're related to you through the same parent. So that's what we call triangulation. 3 people, each of them matches the other 2. They have a common DNA segment common to all 3 of them. It came from a common ancestor of all 3. and that common ancestor is, say, on your father's side. The other thing that can happen is you can have two people who match you in the same region, but they don't match each other. Well, one of them must be matching your paternal chromosome, the other must be matching your maternal chromosome. We call that phasing. You phase them into the one on your father's side and the one on your mother's side. So that's the way the website put those red and blue markers together as to which are related to me on my father's side and my mother's side. So the rule of thumb when you look at these numbers is anything over 30 centimorgans, you should be able to find the common ancestor. Anything over 20, have a look at it. You might find yourself banging your head against a common wall. Talk to the other person, say, where did your ancestors live? What are the surnames in your family? Where did they migrate to? And, okay, if you find you both have a Smith or a Kelly or a Murphy in your ancestry, I wouldn't be jumping to conclusions that they're the same Smith or Murphy or Kelly, but if you both have a Blackwell or a Kett or a Talty or a Marnin or a less common surname, I'd say, well, have a look at that and see, is that where the common ancestor is? If you're looking at numbers down around 10 centimorgans, maybe if you lived in a jurisdiction with excellent records going back to the 1500s, you could find the common ancestor. With Irish records, it's going to be very difficult. If it's under 10 centimorgans, it's probably just noise and you'll never find the common ancestor. But those numbers are just rules of thumb, and if you've good reason to believe there's a relationship, you lower the thresholds. If you've no reason to believe there's a relationship, you raise the thresholds a little bit. So how much DNA do different types of relations share? I prefer this picture. A, it's colourful, it's based on real data. The total length of all the chromosomes is 3,471 centimorgans. A parent and child are going to match everywhere because all of your DNA came from, all of your maternal chromosomes came from your mother. So you're going to match your mother everywhere along the 22 chromosomes. Same, you're going to match your father because all of your paternal DNA came from your father. But you'll only match each of your grandparents roughly along half the length of the chromosomes because half of your paternal DNA came from your paternal grandfather, the other half came from your paternal grandmother. So you'll match each of them half the way along. Then the next one, either the great-grandparents or a great-aunt or uncle or a first cousin, you'll match on about a quarter of the total length of your DNA. But when you go out to third cousins, you'll only match about 80 centimorgans in total. So another rule of thumb is that a total of about 100, that's a close relation up to a third cousin, and you can be fairly clear exactly what the relationship is. If it's under 100, the correlation between the amount of DNA you share and the closeness of the relationship beyond a third cousin and under about 100 centimorgans, there's very weak correlation. You can share more DNA with some sixth cousins than you do with other fourth cousins. And there's another table there that gives you the theoretical figures, which work out pretty close the same to the experimental ones. I won't go through all the numbers. So what can you do with your DNA? This is where we get to the examples. It's like a fishing trip. You're going out fishing in these pools of people who've sent DNA to the 3 big labs to see can you find long-lost cousins who match you. Or you might have a neighbour with the same surname and have forgotten whether you're related or not. You can go on a specific quest to prove that you're related to a person where there's some other evidence to say that you might be. You might have an adoption or something in the family, and an awful lot of people who are using DNA to find their relatives are adopted people or parents of adopted people. I've solved a number of adoption puzzles at this stage, but one of my closest matches when I first did this 3 years ago is an adoptee who's now 80 in England, and she's about my third cousin, and we're not a whole lot closer to finding the common ancestor than we were 3 years ago. If you have a family secret and you want it to stay a family secret, don't put your DNA out there in public. If you have a family secret and you want to get to the bottom of it, DNA is a great way to do it. And people who don't know their genetic ancestry have a huge desire to find it, and I think they have a right to find it. The other thing you get, which I didn't show you, is an ethnicity estimate based on a reference population, which I gather is living people who were able to prove that their ancestors lived in the same area for the last 2 or 3 generations. Most people in this room, I suspect, when they get their ethnicity estimate back, it will say 100% Ireland, or on some of the sites it's even vaguer, it's 100% British Isles. They don't even distinguish between British and Irish ethnicity. But this is a huge selling point in the US, which is a melting pot of people from nations all over the world, and everybody is mad keen to know, where did my ancestors come from and where did my DNA come from? But it's very crude. I said on average you get 1/4 of your DNA from each grandparent, but you might get 32% from one and 18% from the other, and that will quickly skew your ethnicity after a few generations away from the genealogical ethnicity. The genetic ethnicity is the genealogical ethnicity with a random element thrown in. And with anything to do with numbers, you know the phrase about lies, damned lies, and statistics, and you can do all that with DNA. A little commercial for the 3 companies that are doing this. There is a new company called Living DNA, which has just started up in Britain, which is very interested in trying to refine the ethnicity calculations and maybe be able to tell Irish people what county or what province they're from their DNA. But they're only just getting off the ground in the last few months. The biggest company at this stage is Ancestry DNA. Started out as Ancestry.com, putting traditional genealogical records like census returns online. And in the last couple of years, they've discovered that the DNA analysis is a big seller for them. They provide very limited tools for analysing the results. They have tended to overcharge customers from outside the US, but they had 1 million samples by July of last year. They had 2 million samples by June of this year. So you will get the most close relatives, especially if, like everybody in Ireland, you have ancestors or great uncles or great aunts or cousins who emigrated to the US. Their descendants are out there in these databases trying to find you. Let me just show you my results. For some reason it won't open in Firefox recently. So there are my results within the last 7 days. People go by pseudonyms. Some of them might be real names. Princess Cat is hardly a real name. Karen Blank might be a blank surname, or it might be her real surname. In principle, you're supposed to put up your basic family tree so people can look at your family tree for the common ancestor. The first one there has a family tree, the others don't. So you can actually view the match, and is that loading? It will bring up our family tree. We're predicted to be 5th to 8th cousins. If you point at the eye, it will say we share 8 centimorgans across one DNA segment. That's a very distant relationship. There's the surnames in her family tree, and there's the actual family tree. I don't see any names that look even remotely. Aha, we're getting to Ryans. Okay, maybe it's on the Ryan side. They're probably Irish, or the Costello side. You can very quickly pick out on a lot of these American family trees, there's only one branch of the ancestry that could possibly be the Irish branch, if your ancestry is 100% Irish. 23andMe is a company that started out selling DNA analysis as a way to calculate your risks of developing certain diseases, and the genealogy was only an afterthought for them. And they're kind of in limbo. They began preparation for the transition to the new 23andMe experience over a year ago, and it's still going on. And a lot of their matches are completely anonymous and uncontactable. So this is my match who is adopted, the 80-year-old lady I mentioned earlier. I don't have my own DNA at 23andMe. And it eventually will load up her nearest matches. She appears at the top herself. The second lady, we've worked out there's probably a connection in Mayo. The third person, female, no name. Some of these we can see, but there's some down here, there's not even a way of contacting them. So it's very frustrating if you find, oh, my mother's on 23andMe, I was adopted, but I can't see her name and I can't contact her. She's just there for health reasons. But it has one lovely thing. It recognizes that The significance of a surname in the family tree depends on how common the surname is in the population at large. The Kellys and the Smiths and the Murphys are not as significant as the rarer surnames that I mentioned earlier. So it comes up with this enrichment figure. So the most significant surname appearing across the people whose DNA matches Anthea's is Conneely. There's only 7 of them, but it's a relatively rare surname. There are 10 O'Malley's and 11 Joyces, but they're commoner surnames, so it's not as significant to have 11 Joyces in your matches as it is to have 7 Conneelys. And if we go down along Sullivan, she has 15 Sullivans, but everyone in Kerry is called Sullivan, so that's not as significant, or 12 Walshes or 12 Kellys is less significant than 5 Dwyers, and so on. I wish the other companies would do that sort of weighting of surnames to tell you which are the significant ones. Family Tree DNA is the company that I've worked most with. I have 10 kits down here. If anyone wants to sign up afterwards, it's $59 US for the basic autosomal family finder test. And I will have more kits after Christmas if we run out tonight. Family Tree DNA is dedicated to genetic genealogy. It has great analysis tools. It welcomes people from all over the world, so it doesn't have a US bias in the database. It possibly still has more Irish people than either of the other 2 companies. And we even have a Clare Roots project, which was set up after a Clare Roots Society meeting this time last year. It now has 405 members, I think, when I looked earlier today. It has a discussion group, a bit like a Facebook group, where we can ask each other questions or point out discoveries that we've made, so you can see who's recently joined the project. And it has not quite as helpful as it is for the surname projects, but you can actually look at the Y-DNA markers as we did for the Clancy project earlier. I'm one of the co-administrators of this, and I've just grouped the people together by what haplogroup letter they're from. Haplogroup E, haplogroup I. So there's about, the first 15 are from haplogroups A to Q, and everybody else is from haplogroup OR. 145 people. So that says practically all the Irish population is from haplogroup OR, with a few E's and I's thrown in. I showed you my results earlier, we don't need to look at them. So, summary is, what do you get for your money? You get your list of relatives. Those lists are updated as the database grows, as new relatives send in their DNA. You get your ethnicity estimates. You can download your raw data. So whichever lab you send your data to, there's this third-party site called getmatch.com, and you can copy the data file from the lab website, upload it to getmatch.com, and compare with people who've sent their DNA to the other 2 big companies. So one of the cases we'll look at in a minute was somebody who'd been with the other 2 companies for about 2 years and not with Family Tree DNA. She was desperately looking for the ancestors of her grandfather who had been fostered and didn't find me until she copied her results to GetMatch, and then we were matched. So this is my list of matches. Yes, I should shrink that so you can see some form of the names. If the kit number begins with a T, it came from Family Tree DNA. If it begins with an A, it came from Ancestry DNA. If it begins with an M, it came from 23andMe. If it begins with a Z, that's fairly recent because they've now got the same upload procedure for all 3 companies, and they no longer distinguish between where the stuff originally came from. So you can see I have my 2 kits from 2 companies there, so that's why I'm top of my own list. 3 first cousins, first cousin once removed, double third cousin once removed, then this adopted lady who's about a third cousin, fourth cousin, don't know, third cousin, another adoptee, third and fourth cousins. So you can get into this at the very basic level and just look at the names and the places and see if you can find the common ancestor. You can get into the numbers and start looking at centimorgans and half-identical regions. You can get into phasing and triangulation, or you can actually look into the raw data and start looking at all those ACs, Ts and Gs if you want to really solve a puzzle. Depends on how specialized you want to get at it. Make sure you put up a family tree. I encourage everyone to get something like Ancestral Quest or Family Tree Maker or Reunion, and at least put your direct ancestors in it and keep it for yourself and your descendants, and put it up on the DNA website, just the basic direct ancestors, so that people who match your DNA will have some idea of who the common ancestor was, where he or she lived. So for the last 20 minutes or so, I'm going to look at about 5 examples, all from West Clare. This is one that only cropped up last week. This is Moveen West, where my grandmother was born. I think it was Daniel Maloney's farm became McNamara's farm. My grandmother was a McNamara, but she and her half-siblings claim to be related to half their neighbours in the townland. And I'm going to look at the Gormans in number 7 and number 8. This is Griffith's valuation from 1855, and their neighbours, the Lynches, around them, because both families have cropped up in DNA results recently. Here's a little map of Moveen. Don't know if you know Dunlicky Castle, where people fish on the Cliff Road. This map dates from 1840, before the famine. The famous Cliff Drive along the cliffs west of Kilkee didn't exist. There's no road along the cliff edge there. That was built as a famine relief scheme. There's Daniel Lynch's farm, Patrick Gorman's farm, James Gorman's farm, Mary Lynch's farm, and Patrick Lynch's farm. So the Gormans, who in 1855 lived on those 2 farms up near Dunlicky Castle, according to the oral tradition, moved down to Carrigaholt Beach. I bet most of you don't know that. You probably know Carrigaholt and you probably know the beach. You probably don't know that there was a row of houses along there on the beach up to the early 1900s. In fact, I remember first when I started to walk on that beach in the 1970s, there were big lumps of mass concrete and stone wall, which were the remains of the houses which had been claimed by coastal erosion. So these Gormans, who were farmers in Moveen, supposedly fell in hard times, came down to live here for a while, and then they ended up living at what some of us still call Gorman's Cross. If you go back from Kilkee, heading for Loop Head, where you turn right for Kilbaha or go straight on for Carrigaholt, that was Gorman's house eventually. It was Shea's house originally. I discovered a Gorman married a Shea, came up from the beach and lived in that house. But there was a McMahon family in Baltard, the other side of Kilkee, up towards Doonbeg, who somehow inherited or acquired the Gorman farm in Moveen, and I was told we're somehow related. My grandmother's stepmother was one of these McMahons, so my cousin said we're somehow related through the McMahons to the Gormans. So here's the McMahons in the 1901 census. Martin and Anne in their 70s, their son Michael, their daughter Marcella, one of the few Marcellas who didn't get that name from a Blackhall ancestor, but they were neighbours of the Blackhalls. Mariah Kitson, age 6, described as a niece. So how could a 70-year-old have a niece who's only 6? That's a huge age gap between an uncle and a niece. Anybody know? You've got to be very sceptical of the word niece and nephew in these census returns. What's the Irish for a niece? Not? Any other word for it? Gorilene and Gorwalk were used to mean both grandchildren and nieces and nephews. And when translating that into English, I'm sure if we scroll over, show all information, these are probably bilingual. The 4 adults speak Irish and English, the 3 children speak English only. So I have now documented dozens of examples where I know the relationship is grandfather-grandchild, but on the census it appears as uncle or aunt and nephew or niece. So Mariah Kitson, I worked out, is the daughter of, I think, Anne McMahon. She's the granddaughter of Martin and Anne. But who are the Marnons? I put up a post on the Clare Past Forum 2.5 years ago, asking had anybody come across any examples of this, and this was the first example that I picked. In Clunmore, I had found the Cahill family where Willie Williams was a nephew, and I knew Willie Williams was a grandson, not a nephew. In Baltard, I picked this house with the Kitsons and the Marnons. So I scratched my head for about 3 years, and last week I was talking to my American cousin Cindy Wood, who's been adopted by the Marnan clan as their genealogist for their gathering, which they're holding in Canada this summer, and she's doing a big one-name study of the Marnans. I remembered these Marnans, and I said, I wonder, can I find them? And now we have birth, marriage, and death records online since September. You have a search form, which you have a link to there. You can search for any birth registered in Ireland between the beginning of civil registration in 1864. You only have to put in your initials in the form. Sorry, you have to tick the box. I didn't tick it. All the births from 1864 to 1915 are online. So I searched there and I found the birth certificate of the only Michael Marnan who could possibly be the one who was aged 15 in the 1901 census. There he is, the bottom one on the page, born July the 30th, 1884, in Moveen. He's in Baltard, but he's originally from Moveen. His father is Michael Marnan, his mother is Mary Gorman. I was told the Gormans and the McMahons were related. Suddenly we have this guy living in the McMahon house whose mother's a Gorman, who's described as a nephew. I eventually decided he must be a great nephew. I found that James Gorman married Margaret Shea. The house at Gorman's Cross that I showed you, that was the Shea house. He married into that house. So I'd been told that James Gorman's wife was McMahon. That didn't tally when I looked at the marriage register. But then now it's beginning to look like the McMahon was a generation further back. So then we did a little bit more work, and we discovered that the nephew and niece in the grand uncle's house, he's not their uncle, he's their great uncle. So one of his nieces is his granddaughter, his other niece is his great niece, and his nephew is his great nephew, really. So here's Bridget, born December the 28th in Moveen in 1880 to Michael Marnan and Mary Gorman. So by the 1901 census, she's probably already emigrated. And we looked at the user-submitted family trees at ancestry.com. And here's Richard Dino's family tree. And he's stuck at his great-grandmother Delia Marnan. He has all the great-great-grandparents filled in except Delia's. I suspect he's one of the many Americans who doesn't realize, as everybody in this room I'm sure knows, Delia and Bridget are the same name. Fidelia is the Latin for Bridget, and it's usually shortened to Delia. And everyone in West Clare probably has a Delia in their family. But if we look at his precise information, he knows she was born on the 28th of December 1880 in Ireland, exactly the date we had on the birth certificate a minute ago. So I think she's probably the same person. So I said, well, he's on Ancestry.com. He's probably sent his DNA to Ancestry DNA. Two of my cousins have given me access to their Ancestry DNA results, and they're also descended from the same McMahon family. Descended from Patrick, a brother of the Martin in the census return. Delia Marnan's descendant shows up as a DNA match to both of them. So I think that proves pretty emphatically that it was true that the Gormans and the McMahons were related. Just in the retelling over the generation, somebody skipped a generation, and the DNA has now proven that the niece and nephew in the census return were really a great niece and a great nephew, that the oral tradition handed down was almost right, and we can even go back to this man in Massachusetts and say, we have 3 extra generations of your ancestors. We know Delia's parents, Michael Marnan and Mary Gorman. We know her grandparents, Patrick Gorman and Bridget McMahon. And we even have a tombstone inscription from Killard Graveyard, erected by Pat McMahon in memory of his father Edmund and his mother Johanna McMahon alias Lynch. The dates are a bit out. If you look on the website, somebody's read 1850 as 1880, but I've examined the original and it does say 1850. And I think the transcription says Lyons rather than Lynch, but the original I make out to be Lynch, and that was what the descendants always told me. How do we know she was Bridget? We have this article from an 1863 newspaper at a late Carrigaholt Petty Sessions. Thomas Lynch, who had been on 2 previous occasions remanded in consequence of Bridget Gorman's continued illness, on whom he was charged with having committed an assault on the 1st of July at Moveen, while she was attempting to impound his cattle, was again remanded for 8 days on the evidence of Dr. Mahoney, who would not undertake to say that the woman was out of danger. I have been told the story in the local folklore as well. I was delighted to find it reported in the newspapers. It's 153 years ago now. I hope I'm safe in mentioning it and that I won't be lynched for bringing up centuries-old land disputes or whatever was behind it. So now let's move across the ditch. I showed you those pictures of Moveen where the two Gorman families were side by side. Here's the map again. On either side of the Gormans you have two Lynch families, and you have another Lynch family down there. And we, when I say we, several of us have already submitted DNA, started getting matches with a Lynch family from California in recent months. 7 siblings from the same family sent their DNA to the various DNA companies. And they're the grandchildren of a man known either as Eugene or Owen Lynch. He died in San Francisco in 1917. He'd abandoned his pregnant wife and children a few years before that, and all they really knew is he was born in Ireland about 1869 or 1870. No idea what part of Ireland. But the DNA results started coming back with lots of close matches in West Clare. Again, I say try and combine the oral tradition, the written archival record, and the DNA evidence. The oral tradition that I collected years ago was that there was an OD farm in Moveen West where we saw Mary Lynch on the map a moment ago. The OD farm was divided between 2 sisters. One of them married a Lynch, the other married a Connell. Must have happened about 1820, because in the Tithe Allotment book for 1827, which is online on the National Archives website, somewhere down here we have Michael Lynch's division, and 2 places below him Pat Connell's division, and Michael Lynch had 15 acres and Pat Connell had 16 acres in Moveen West, which you see written up the left-hand side there. So that looks like the evidence of the Tithe Allotment book from 1827 matches the oral history of how the land was subdivided. We go back to the Griffiths valuation page. The Connells are nowhere to be found in Moveen for some reason. Again, there may have been a land dispute. Mary Lynch is the occupier of the whole farm, 68 acres. It's a bit bigger. The Tithes is 31 Irish acres. The Griffiths is 68 statute acres. And the ratio is 196 to 121. So it's still slightly more. However, she extended her holding between 1827 and 1855. So we have 2 people, one whose mother was a Lynch, one whose mother was an O'Connell, who sent off their DNA, and when I compared them, I discovered they had this very long segment in common, 50 centimorgans, 10,000 snips. According to the family tree, they're only 4th cousins, so that's a lot of DNA for 2 4th cousins to share in one segment. But not only that, they share about half of this segment, 27 centimorgans, with Michael Lynch in California. So the Lynch descendant and the O'Connell descendant, their common ancestors were the 2 OD sisters. So this is actually a segment of OD DNA which has come down through the Lynch line and through the O'Connell line. But it's also come down through a second Lynch line to the Californian Lynches. So we were able to tell the 7 siblings and around Sacramento, we're certain your ancestors were Michael Lynch, who married Mary O'D, and they lived in Moveen. They must have got married shortly before the Tithe Allotments in 1827. They had another son, Daniel, who emigrated to Newtown, Connecticut, which was a great place for West Clare people to emigrate. And we have Daniel's death certificate from Newtown, confirming his father's and mother's name, again confirming the oral tradition. So as soon as they heard this, 5 of the 7 siblings booked a flight to Ireland, and they were here a couple of weeks ago. We haven't figured out who Eugene's father was yet, but we know his grandfather based on the dates. He couldn't be a son of the couple who were married by 1827, but he couldn't be much more than a grandson either. So we're looking for some son of Michael Lynch and Mary O'D, who had a son called Eugene. We have somebody else who we hope is going to give us a DNA sample to see is she a second cousin of the people who visited. So just to show you some of the pictures that we took. Well, they were here last week. These are up on Facebook, but I think you have to be Michael's friend to see them. Here's one of the California lynches with one of his Clare cousins, a third cousin. I guess she's his fourth cousin, found through DNA. There's me with the Californian on one side and the Clare cousin on the other side, and another returned immigrant from Oveen who came with us for the day. There's Michael and, God, I can't remember the names of each of them now. Two more of the sisters from California, and we brought them out to Oveen and showed them the houses. There they are on the steps of the Stella Maris with all their Clare friends. There they are. Now there we are trying to get information out of the Oveen locals. There's roughly the farm where their ancestor left from. Somebody who knows, does anybody who knows Oveen know who lived in that old ruin of a house? With what somebody described as a prehistoric surfboard recycled as a wooden mantle. So there's four of the Californians with their Oveen cousin, delighted to be back in California. We brought them to the cemetery, showed them the Lynch graves. And the OD graves, because there was a drowning tragedy in Oveen in 1888 when 3 Lynches and 2 ODs drowned. And we think the Lynch man who drowned may have been Eugene's father, but we haven't proven that yet. There they are at a Lynch grave. Michael O'Connell laying down the law. There's the other Lynch grave. We think this might be the Lynch family most closely related to them in Oveen. There's various other pictures there. But it's really satisfying when you get an email back from somebody like this. That day was the highlight of our trip to Ireland. For me, it was an unbelievable gift. I have been wondering and imagining for so long about my grandfathers and thus my own origins that I still quite can't believe I went there. It was a profound and moving experience for me. My sister Pat and I speak of it often. It was magical to us. Both of my parents were from families who didn't stay connected with their homeland, and this journey has really fulfilled a need that I hadn't realised I had. I'll be forever grateful to Tom Carney for introducing me to you, and to you for so generously sharing your expertise with us. So it's nice to get something like that. Without the DNA, we could never have done that. I better fly through the others now because I'm nearly out of time. This is another West Clare story which one of the descendants said I should entitle From a Little Cottage in Clare. Remarkable coincidence, in the summer of last year, on the 10th of June, through the Clare Roots Society, I got in touch with a man in New York who was a descendant of the Downs family coming to Clare to mark his 50th birthday. 9 days later, I saw this new match on getmatch.com, the comparison site for DNA from all 3 companies. It was one of the biggest matches I'd seen, 44 centimorgans, 8,000 snips. The lady's name is Dana, and we figured out after a couple of days what the connection was. I'll show you the details in a minute. The 8th of July, a couple of weeks later, I get an email from William Brown. He matches my Mayo first cousin. Small little match, 10 centimorgans, 2,000 snips. I said, what the hell is he even bothering me for? We'll never find the common ancestor. But I looked to see who else did he match, and there at the top of his list was Dana, who had shown up on my list a couple of days earlier with 2 big matching segments, 30 centimorgans and 19 centimorgans. So I said, well, he's pretty closely related to Dana, even if he's very distantly related to my Mayo cousin. And he does have Mayo ancestry as well, so maybe he is distantly related to her. Turns out all these 3 people who showed up within less than a month of each other are descended from immigrants who emigrated from the same house in Clare. 2 of the 3 had children born out of wedlock, which is why they were a little bit in the dark about their exact ancestry, but they both had the Downs surname at least. Turns out they're double third cousins once removed to each other, and Dana is my 4th cousin, descended from Hugh Clancy and Marcella Blackwell again. I'm not related to Bill. But the interesting story is, why had Dana got no knowledge of her Clare ancestry? Her grandfather was known as Raymond Downs, but he had come to Texas on what they called an orphan train. He'd been born in the New York Foundling Asylum. Turned out he had been conceived in West Clare. We found both of his parents passing through Ellis Island. If we look at line 22 on this manifest, down here we have Kath Downs, aged 18, a servant, from Queren, spelled with one R, bound for New York, passage paid by her cousin. She had $15, no cousin's name. She's going to her cousin at 518 Lexington Avenue. And if we look at the date on that, and the date on which Raymond was born in January, Catherine sailed in September, so she's about 6 months pregnant going to New York. Henry Clancy was hard to find because the transcribers transcribed his name with a W instead of an N. He's on line 22. He left on the last day of the 1800s. Henry Clancy, age 22, male, single, labourer. Can't read some of this scroll. He gave Kilrush as his home place, even though he was from Killard. He's bound for Terre Haute, Indiana. Only that I knew that from some other sources. I never have read that. And he's going to his cousin, Mrs. Haley, at some address in Terre Haute, Indiana. And sure enough, we find him in the census in Terre Haute. But first of all, we find the newborn Raymond, born in Manhattan, 24th of January, 1900, given his mother's surname, Downs. Sorry, I should have checked what line I'm looking for. He's line 72 on this form. Top of the page, Downs, Raymond. This is the Foundling Asylum, white male, born January 1900, aged 4/12 of a year, and very little other information about him. His mother is surely the Kate Downs, who was, even though it says born in New York, she was an inmate and a nurse in the same institution on the same date. She's on line 91. 91. So the only thing that puzzles us here, Kate Downs, born May 1880, which is roughly right, but it says she's born in New York to New York-born parents. But you often get in institutions where somebody in charge of the institution is filling in the details of dozens of people, they'll get things wrong. I'm certain it's her. Harry Clancy was on line 68 in Terre Haute, Indiana, where he said he was going on his passenger list. Clancy, he's Harry now. Again, if you're searching for Henry, you've got to be a little clever to find him as Harry. He's a boarder with the Haley family. And if we scroll over, he's born 1874, born in Ireland, parents born in Ireland, migrated in 1899. He's only 6/12 of a year here, which fits perfectly with him arriving in January, and the census is in June, and he's a car blacksmith. So it turned out about 1904, the child who'd been reared in the Foundling Asylum is sent off to foster parents in Texas, known as Raymond Downs. Probably a couple of months later, Henry Clancy of Clare comes back from Indiana to New York, marries Catherine Downs, brings her back to Indiana. One would hope they lived happily ever after, but they probably always wondered what happened to the son that was taken off on the orphan train. They had one more child, Margaret. She never married. Did she know she had a full brother living in Texas under a different surname? And I'll just fly through the last example. Some of you heard me give this talk about the Talty Millions case, maybe in the old Kilfarboy Society a few years ago. My great-grandfather was the heir to his first cousin's estate. There's lawyers in the room, so I better not say who got most of the money, but some of the first cousins of the deceased got some of what wasn't really millions. It was hundreds of thousands. It was right before the stock market crash in 1929. So by the time the money was distributed, it was worth a lot less. They could not find any brothers or sisters of T.J. Talty who had died in New York, but they found first cousins all around the world, distributed the money to them. But a few years ago, I found this girl in Australia, Christiane, looking for information on her ancestors, and she sent me their marriage certificate. What's going on here? And if we blow this up to about 100% and scroll down, there's the marriage of Donald McCaskill in Sandhurst, Victoria in 1868 to Mary Talty, spinster from Milton Malbay, County Clare, aged 22, daughter of Timothy Talty and Margaret McNamara, Timothy a storekeeper. I said, could there really be two Timothy Taltys married to two Margaret McNamaras? The lawyers would never give the estate to the wrong heirs. They must be two different parallel families. But then Christiane sent off her DNA, and back came the results. and she has this big match with myself and my first cousin Anthony. If her ancestor was the sister of the man who died leaving the millions in Florida, then she's my fourth cousin twice removed, and then her ancestors' children in Australia should have been the heirs to their uncle's estate, not the first cousins who actually got the money. But why I queried the ethnicity estimate, she has this one Irish great-great-great-grandmother, whatever generation it is, and the other ancestors are from all over the world. She's 47% Eastern Europe, 43% Western and Central Europe, 7% Finland and Northern Siberia, 3% Asia Minor, 0% British Isles ancestry. But myself and my cousin are two of her four closest matches, and we're 100% British Isles ancestry. So the ethnicity and the relationship lists don't always match. So just a summary of how closely we're all related. One of the last sets of results that came in back in October, I looked at the 30 top matches for gentlemen from West Clare, and I realised I knew 7 of these 30 people, and I was going out that evening to meet an 8th who was on a visit from Chicago to Dublin, where I was on that day. 6 of these were people whose DNA I collected myself. Only one of them was a known relative to the person whose results had just come in. So I think we're all related. If we go back as far as 4th, 5th and 6th cousins in West Clare, the DNA would tell us that. The paper trail doesn't go back far enough to find the common ancestor. I did a calculation years ago that any 2 randomly selected Irish people are probably 12th cousins or closer. You bring that down to a smaller population like Clare, I'd say 95% chance for 9th cousins or closer. You bring it to the West Clare Peninsula, where everybody married somebody from within a 5 or 10 mile radius, and most of that 5 or 10 mile radius was the Atlantic Ocean or the Shannon Estuary. We're probably a lot closer related. In fact, in our Clare Roots project, there's one lady who is deemed to be related to more than 10% of the people in the project, and they tell us that DNA will only pick up about 10% of our 5th cousins, so she seems to be on average closer than 5th cousin to everyone in Clare. And there's a great story from Mark Humphreys in Dublin City University, which came out, I think, when RTE did Who Do You Think You Are, and they proved that Ryan Tubridy descended from Brian Boru, and he wrote this article for the Irish Times. He said, Ryan Tubridy descends from Brian Boru, and so do you. Brian Boru lived 30 generations ago. 10 generations ago, we all had 1,000 slots on our family tree to fill in direct ancestors. 20 generations back, we've had 1 million slots to fill in. 30 generations back, when Brian Boru was alive, we've had 1 billion slots to fill in. There was nothing like 1 billion people in the world, let alone in Ireland. There's going to be a lot of repetition. We know Brian Boru has descendants alive today. We can be pretty sure he appears many times in all of our family trees back around the 30th generation. So why you should submit your DNA? The more people in the databases, the easier it is to put the family trees together. Not only is it of value to you, it's of huge value to the other people in the database to have a bigger database, especially to the adoptees and others who are struggling to put together family trees with no relationship. Even if they're only your 3rd or 4th cousins, you might be the critical clue that helps them to break through the brick wall. The more Clare people we get in there, the better. And your descendants will be eternally grateful to you for leaving your DNA in the databases for them, because this technology is in its infancy and it's going to improve beyond recognition in the next 5, 10, 20 years. And when your young children and grandchildren grow to the age where they get interested in their ancestry, they will have the technology to draw a lot more information out of the data that you have banked for them at this stage. And there's a further reading list at the end that you can follow up the links yourself. So I didn't go too far over time, I hope. Thank you all very much for listening. Any questions?